Hey, what's going on, everyone? How are you all doing today? So today we're continuing with Unit 6, Right Triangles. And as always, before we begin this lesson, make sure you have a pencil, an eraser, your notebook out. So make sure you pause the video, gather all those items, and then we can resume. And then, like I've done in the past, I've put red stars next to the slides that should be in your notes. So anytime you see red stars next to the heading of that slide, you should, or it would be a good idea to copy those slides into your notes. So once you have all those things, let's begin. So yesterday we looked at 45, 45, 90 triangles. Today we're going to be looking at 30, 60, 90 triangles. So hopefully after today you guys will be able to identify special right triangles and identify and apply the relationship between the length of sides of 30, 60, 90 triangles. So here we have a 30, 60, 90 triangle. And this is just very important to know as we move forward. So the longer leg, as we see right here, that's going to be the side across from the 60-degree angle. Here we have the 60-degree angle. See how it's directly across? And then we have the shorter leg. That is going to be this side right here. And that is across from the 30-degree angle. So if this is our 30-degree angle, that's going to be our shorter leg. And then we all know that the hypotenuse, it's actually the longest side, but we're just going to call it the hypotenuse. And that's right across, directly across from the right angle, which we have here. And it's important to know, to clarify these just so we can move forward. So we're going to do a little discovering activity like we did yesterday with the 45, 45, 90 triangles. It's going to be a little similar. So we're going to start by drawing an equilateral triangle, and I recommend using pencil because you may have to do some erasing with this. We're going to assign a random number to the side lengths, and I recommend choosing an even number, and you'll actually see why in a minute. Bisect one angle to cut the triangle in half, also bisecting one segment, and find the length of the legs of the triangle. Write their lengths in simplest radical form. So that's kind of a lot of directions, but I'll actually go over this with you. And we want to, like we did last time, record our results in a table like we have here. So I'm going to start out. So that was a lot of information. If you're kind of lost, no worries. I'll walk you through the steps. So first we want to start by drawing an equilateral triangle. So let's say this is an equilateral triangle. It's not perfect, but it'll work. And if this is equilateral, this is going to be 60 degrees. This is going to be 60 degrees. This is going to be 60 degrees. And then we want to assign just a random side length to these. And I recommend choosing an even number. And this will be why. So if this side length is 10, this side length is 10, and this side length is also 10, we have our equilateral triangle. Now we want to take an angle and bisect it down the middle. And this is why I recommend using pencil, just so we can erase here. Once we bisect that angle. And when we bisect it, this line is going to be perpendicular to this line, so that will form a right angle. And because it's bisected, what does that mean again? What does bisecting mean? Right, it means to cut in half. So if we cut this angle in half, this angle is going to be 30 degrees, and this angle is also going to be 30 degrees. Now, if we bisect this line segment as well, again, we want to cut it in half, so this has a length of 5, and this has a length of 5. And that's why I just recommended using pencil, because we're going to do some erasing here. And then if we choose an even number here, then we get an integer here rather than a fraction or a decimal. So now we have our 30, 60, 90 triangle. We have a hypotenuse of 10. Our shorter leg is 5. So let's solve for, let's call this A. Let's solve for A. So how do we solve for A? Right, we're going to use the Pythagorean theorem. A squared plus 5 squared equals 10 squared. So we get A squared plus 25 equals 100. A squared, oops. I'm going to subtract 25 from both sides. Subtract 25, so we're left with a squared equals 75. And we take the square root of both sides, and we're left with a equals square root of 75. Now, is that in simplest radical form? Right, it's not, but we can simplify that a little bit further, so it is. So a is going to equal, is there a perfect square that goes into 75? 25 does, and 25 is a perfect square. So we know 25 times 3 is 75, so root 25 times root 3 is going to equal root 75. Now the square root of 25 is just going to be 5. So a equals 5 times the square root of 3. And that's in simplest radical form. We can't break that down any further. So I'm going to go ahead and go to my table, and we see when our short leg is 5, our longer leg is 5 root 3, and our hypotenuse is 10. So our short leg is 5. Our long leg is going to be 5 square root of 3, and our hypotenuse is 10. Now let's look at another triangle. So I'm going to draw another equilateral triangle. And I'm just going to assign a side length of 4. Let's say these lengths are 4. And again, this is 60 degrees. This is 60 degrees because it's an equilateral triangle. And we're going to bisect it down the middle. So that would make this length 2. And that would also make this a right angle. And this one would be 30 degrees because we bisected it. Now, to solve for a, we do the same process. And I chose the numbers 4 for this one. You could do 4 as well if you want to follow along with me, or you could choose your own numbers and see if you notice a pattern. But let's solve for a, saying that the hypotenuse is 4. So we're going to do a squared plus 2 squared equals 4 squared. So a squared plus 2 squared equals 4 squared. A squared plus 4 equals 16. Subtract 4 from both sides. A squared equals 12. Now we're going to take the square root of both sides, and we get a equals the square root of 12. Now, we just need to simplify this so it's in simplest radical form. Does a perfect square go into 12? Yeah, one does. 4 times 3, and 4 is a perfect square. So we could say that a is equal to the square root of 4 times the square root of 3. A equals, well, square root of 4 is just 2. 2 times the square root of 3. So when we have a short leg of 2, our longer leg is going to equal 2 root 3, and our hypotenuse is 4. So I'm going to go back to the table. Our short leg is 2. Our long leg is 2 root 3. And our hypotenuse is 4. Do you guys notice a pattern yet? Between the short leg, the long leg, and the hypotenuse? Maybe you do, maybe you don't. Let's try one more, just to be safe, and see if the pattern continues. So let's draw one more equilateral triangle. And again, this is going to be 60 degrees. This is going to be 60 degrees. And I'm going to give this a length, or give these a side length of 6. And again, you guys could choose any number. I recommend an even number just because it's easier, but I'm going to do 6. And then bisect it down the middle so that this angle is 30 degrees. And so this would have a length of 3. And we know because it's bisected, that's a 90-degree angle. All right, if we call that side length a, let's solve for a here. We know that a squared plus 3 squared equals 6 squared. A squared plus 9 equals 36. Now we're just going to subtract 9 from both sides. We're left with a squared is equal to 27. Take the square root of both sides. A equals the square root of 27. Now is that in simplest radical form? Not yet, because 9 is a perfect square and 9 is a factor of 27. So I'm running out of space, but I'm just going to try and squeeze this in right here. So a equals a square root of, we know 9 times 3 is 27, so root 9 times root 3 is going to equal root 27. Now the square root of 9, we know that to be 3. So a equals 3 times the square root of 3. So when our short leg is 3, our longer leg is going to have a length of 3 root 3, and our hypotenuse is going to be 6. So let's make sure we record that. So 3 3 root 3, 6. Do you guys notice a pattern yet? Try to see if you can figure it out on your own. Here's what I noticed. So if we have a short leg of length x, then we multiply the short leg by the square root of 3 to get the length of our long leg. So we could call that x times root 3. And our hypotenuse, well, that's just twice as much as the short leg, or double the length of. So x will become 2x. And this will lead us right into our formulas that we'll be using for the 30, 60, 90 triangle. So our hypotenuse is just going to be 2 times the length of the shorter leg, and our longer leg is going to be the shorter leg times the square root of 3, as we can see in these diagrams. X times square root of 3, 2x, x times root 3, 2x. So these we will use going forward, and they'll be very important with solving 30, 60, 90 triangles. So I'm going to show you an example. You guys can follow along with me with this one, and then you're going to do some on your own. So this one's also going to be a little bit trickier. I'm starting out with a more challenging one, and then the ones that you guys will do on your own will be, they'll start out slightly easier, or involve less steps at least. So this angle is 30 degrees. We have a 90-degree angle. That must mean this is the 60-degree angle. And 10 is the length of the longer leg. So what I recommend is you always want to solve for the shorter leg side first. Just because we know if we find the shorter leg, then we just multiply it by 2 to get the hypotenuse. Or if we're not given the longer leg, then we're just going to multiply the shorter leg by the square root of 3 to get the longer leg. So if you're given the shorter leg, that's great. It's a lot more straightforward to find the other sides. But if you're given the length of the longer leg or the hypotenuse, I always recommend finding the length of the shorter leg first. So we know that the longer leg is 10, and our formula is going to be long leg equals short leg times the square root of 3. So there's our formula. So our long leg is 10 equals x times the square root of 3. Now we're just going to divide both sides by 3, or by root 3. So we're left with 10 over square root of 3 equals x. Is that in simplest radical form though? No, it's not, because we have a radical in the denominator. So to get rid of that, we're just going to multiply this by root 3 over root 3. So we're left with x equals 10 root 3 over 3. So now we have found x. Now how do we find y? Well, remember, we just want to double the length of the shorter leg to get the hypotenuse. So I'm going to write the equation hypotenuse equals 2 times, and then I'll just use SL for shorter leg. So our hypotenuse is y equals 2 times 10 root 3 over 3. So y is going to equal 20 root 3 over 3. We could simplify that to make it a mixed fraction if you want, but that's in simplest radical form. We don't have a radical in the denominator, so those are acceptable answers. So that is how I solve for that one. Now you guys try these on your own. So find the value of each variable, leave your answer in simplest radical form. So for this first one, if you got an answer, so make sure to pause the video, try it out on your own. If you got an answer of 4 over the square root of 3 for A, and then for B you got an answer of 8, then you're set. You can fast forward through that problem. If you didn't, I'm going to show you how to do it. So we know that the shorter leg is 4. So I'm going to solve for the hypotenuse first. So we know hypotenuse equals 2 times the shorter leg, or the length of the shorter leg. So hypotenuse equals 2 times SL. So B, our hypotenuse, equals 2 times 4. So B is equal to 8. Now to get A, that's the length of the longer leg. I'll call that LL. Longer leg equals shorter leg times the square root of 3. Longer leg is going to be A equals 4 times the square root of 3. And that is in simplest radical form. Now let's look at this one. We have our shorter leg equal to 11 root 3. So try and pause the video, see if you can get it on your own. If you got an answer of 33 for M and 22 root 3 for N, then you're all set and you can fast forward through the explanation. If you didn't get those answers, follow along with me and copy it into your notes as I do it. So we know our hypotenuse is going to be equal to 2 times the shorter leg. And I'm just going to keep writing the formula each time. If you have it down, you don't have to keep writing it like this each time. You could just plug the numbers directly in. But I'm going to do it just each time just so I can get the hang of it and just so you guys, so it's more, or so there's less confusion, I should say. So our hypotenuse is N. N equals 2 times 11 root 3. So N is going to equal 22 root 3. Now to find M, we want to do longer leg, so LL equals shorter leg times the square root of 3. Our longer leg is going to be M equals 11 root 3 times root 3. So M is going to equal 11, well, root 3 times root 3 is root 9. So 11 times the square root of 9. And we can simplify that further to M equals 11 times 3, because that's the square root of 9. So M is equal to 33. All right, now we have slightly more challenging example problems. So these are slightly more challenging because we're given the length of the hypotenuse. Those we were given the length of the shorter leg. So already had that. So now we have to work backwards to find the lengths of the shorter legs. So pause the video, see if you can get this one on your own. If you got an answer of x equals 12 and y equals 12 root 3, then you're all set. You can fast forward through the explanation. If you didn't, however, then it might be a good idea to follow along with me. So let's solve for the shorter leg first. So hypotenuse is going to equal 2 times the length of the shorter leg. Our hypotenuse is 24 equals 2 times x, divide by 2, and we get 12 equals x. Now, to get y, we know that the length of the longer leg, so longer leg equals shorter leg times the square root of 3. Our longer leg is going to be y equals 12 times the square root of 3. Now, let's look at this problem. So we need to find j and m. So pause the video, see if you can get this on your own. If you got an answer of m is equal to 13 halves or 6 1/2, and that j is equal to 13 root 3 over 2, then you're all set and you're able to fast forward through this explanation. If not, I'm going to show you how to do it. So we know that the hypotenuse is 13, and let's solve for the length of the shorter leg first. So that's going to be m. So we know hypotenuse equals 2 times shorter leg. 13 equals 2 times m. Divide by 2, divide by 2. And we could leave this as 13 halves equals m, just so it's a little bit more straightforward going forward. If you want to leave it as 6 1/2, that's totally cool too. So now j, the length of the longer leg equals shorter leg times the square root of 3. So j is going to equal 13 halves times the square root of 3. So j is just going to equal 13 root 3 over 2. And we can't break that down any further. All right, so now some even more challenging problems, which you guys can definitely do, I have faith. So let's see, this time we're given the length of the longer leg, and now we have to find the hypotenuse and the shorter leg in both these examples. So let's find the length of the shorter leg first. So we know that longer leg equals shorter leg times the square root of 3. Oh yeah, I forgot to mention too. With this one, so pause the video, try to get it on your own. If you got an answer of t is equal to 12 and s is equal to 24, then you're all set. You did it correctly. If not, follow along with me as I do it. So our longer leg is equal to the shorter leg times the square root of 3. So 12 root 3 is equal to t times the square root of 3. So we're just going to divide both sides by the square root of 3. Those will cancel, and we're left with 12 equals t. Now to solve for s, we know that the hypotenuse equals the shorter leg times 2. So s is going to equal to 12 times 2. So s is equal to 24. Now for our last one, try and pause the video, see if you can get it on your own. If you got an answer for for j is equal to 5 root 3 and p is equal to 10 root 3, then you're all set. You did it correctly. If not, I'll show you how to do it. So let's try and find the length of the shorter leg first, so that's going to be j. So we know that the length of the longer leg equals to the shorter leg times the square root of 3. So 15 equals, so our shorter leg j times the square root of 3. So we're just going to divide both sides by the square root of 3. So we're left with 15 over root 3 equals j. Is this in simplest radical form though? Right, it's not, because we have a radical in the denominator. So to get rid of that, we're just going to multiply this by root 3 over root 3. So we're left with j equals 15 root 3 over 3, because root 3 times root 3 is root 9. Square root of 9 is 3. And then we can even simplify this further, because 15 divided by 3 is going to equal to 5. So j is equal to 5 root 3. Now, once we have j, we can find p. So p is our hypotenuse. Hypotenuse equals the shorter leg times 2. So our hypotenuse p is equal to 5 root 3 times 2. So p is equal to 10 times the square root of 3.